Hello, everyone. The first panel of the afternoon is the government panel, and we have three people here from different agencies that are very concerned with energy and the standards for that. So we'll start off with Eric Toone, who's from ARPA-E, which is an organization set up within the Department of Energy that was styled after our friend DARPA. So, Eric?
Thanks very much, and thanks for the opportunity to be here this afternoon. It's a pleasure to have the opportunity to address this group. So what I wanted to do today then was to give you a brief introduction to ARPA-E, who we are, where we came for, and what we have been doing to date. So ARPA-E was created on the basis of a recommendation from the National Academies to the Congress in the Rising Above the Gathering Storm report. The agency was actually created under the Bush administration in 2007 under the America Competes Act, but unfortunately not funded. In 2009, with Secretary Chu, who was one of the authors of the Gathering Storm report, running the Department of Energy, the agency came to life in a meaningful fashion through $400 million in Recovery Act funding that was announced by President Obama on April 27th of 2009. If you just look at the language in the statute that enables us, our goals are to enhance the economic and energy security of the United States and to ensure U.S. technological lead in developing and deploying advanced energy technologies. The means by which we are to do that is to work towards reducing energy imports, to reduce energy-related emissions, including greenhouse gases, and to improve efficiency across the entire energy sector. So what is an ARPA-E project? The first thing that we look at is impact. We are an agency that is designed to look at over-the-horizon novel technologies that are basically too crazy for anyone else in Washington to fund. And so the first thing that we look at is would this really be an impactful technology? We're not interested in incremental advances to existing technologies, moving things down existing learning curves, not because that's not important. It is very important. It's just not what we do. We're interested in technologies that would move us to whole new learning curves. So we're interested then in identifying technologies that don't exist in today's market and perhaps have not even yet been conceived of. Obviously, we're interested in attracting best-in-class people to energy, and one of our real areas of emphasis over the past 18 months has been to attract a group of people who have not traditionally been involved in energy research to the energy game. And then, of course, additionality. We work within the context of a much, much larger agency, the Department of Energy, and so we work very closely with all of our friends in science and in EERE and other agencies to ensure that there is true additionality in the things that we do. If you look at where our money has gone, we really have focused on early stage technology development. So we're not basic science. We don't do basic science. We don't do late scale stuff. We don't do demonstration deployment sort of things. What we do is early stage technology development. The fundamental scientific principles have more or less been established, and the question that we seek to address is there a technology that can be based on those fundamental scientific principles? And then there are other agencies that we can hand things off to. So as you might imagine then, the vast majority of our funding has gone either to university performers or to small businesses, because that sort of dividing line, often right where things leave the university and go into the private sector, is where our sweet spot has really been. But we have funded large companies as well. We funded General Motors, we funded DuPont, and a number of national lab leads as well. Our first funding opportunity came in April 27th of 2009, when President Obama announced our first solicitation, a very broad, wide open, send us all your cool ideas about energy, and $400 million in funding. At the point that President Obama made that announcement, there were no actual employees at ARPA-E, which made for a very interesting summer. That solicitation attracted 3,700 pre-proposals that were winnowed to about 320 that we requested full proposals of. Those passed through 6 topical review panels, effectively NIH study sections, and resulted in us funding 37 projects. for a total of $151 million. So our projects average right around $3 or $4 million. There's quite a wide range in the dollar value that we support. We've funded things that as small as $500,000. We've made awards as large as $10 million, but $3 or $4 million sort of seems to be our sweet spot. We made investments across the entire energy spectrum in that first solicitation, focused within particular areas. So for example, in the area of biomass, we really focused on sustainability and pretreatment, which we see as the two most significant barriers to the broader deployment. Carbon capture, solar fuels is really photosynthetic organisms. That is a term has a slightly different meaning in the Office of Science. Vehicle technologies, 5 projects, very interested in renewables, wind and solar as well. Building efficiency, some of the lowest hanging fruit in the whole energy space is in the efficiency area. We're very interested in efficiency. Of course, about 60% of all the energy our society uses is lost as waste heat, so novel approaches to waste heat capture is important. There's a clear water energy nexus, and we're very interested in water. I think you'll see us make additional investments in those spaces. Energy storage, both for the electrification of transportation and grid scale storage for the deployment of renewables. This is a meeting today on the use of information technology in energy space, so I just wanted to highlight one of the awards that we made in that first solicitation, an award led by Stanford University. This is quite a large operation. I think there are a dozen PIs here, and the idea here is to use novel approaches to collecting information about energy use, find ways to convert that information into a usable form, and then to study how humans process that information and make decisions about energy use. So the kinds of things that are underway in the context of that award is understanding human motivations to store energy, looking at a variety of smart meters and seeing how they actually impact decision-making and energy use, and then novel approaches to disaggregating complex information from single sensors to increase the amount of information that's available from those devices. So that was our first solicitation. After that first broad solicitation, we sort of fell into a pattern of making more focused investments that averaged sort of between $35 and $50 million each. Those appeared in 2 groups of 3 awards. The first of those awards is a program that we call electrofuels. This is a novel approach to using solar photons to generate energy-dense, infrastructure-compatible liquid fuels without going through photosynthesis. So, of course, all of the liquid fuels that we use now, be those ancient hydrocarbons that are buried in the earth or corn-based ethanol, whatever you'd like, in all of those instances, solar photons are captured through photosynthesis. We're looking to see if there might be other more efficient ways to capture those photons, but use biology to generate the complex molecules that we use as fuels. Electrification and transportation is clearly an important area of research. We know that there are electric vehicles coming to market this year. Those vehicles have fairly limited range. To alleviate sort of range anxiety, we need batteries that are capable of powering vehicles for on the order of 250 or 300 miles. And so novel battery architectures that might allow the gravimetric and volumetric energy densities that are required to enable those sorts of things is an area of interest. Coal is 50% of our energy and will likely be with us for a long time in this country. Ways to decarbonize coal could be attractive. So we've all heard about CCS. There's 3 pieces to CCS: capture, transportation, and storage. It turns out that the expensive and energy-intensive component of that is the capture part, the capture of CO2 from relatively dilute effluent streams that come out of a traditional pulverized coal power plant. And so we're exploring novel approaches to capture that carbon. The second round of 3 solicitations included one on the development of power electronics. So almost everything that we use runs through power electronics, and there's been virtually no research in this field for the past 50 years. So an effort in power electronics really at different scales, one that could be used in substations and in the transmission grid, one that's very important for automotive applications, both for charging and for the conversion of electric power to motive force at the rear wheels to drive things. and then also power electronics for the control of motors. Just crazy things like almost all motors that we use in industrial settings run through a gearbox because nobody's developed the power electronics to make variable speed electric motors. Things like that. Buildings consume a huge amount of energy. One of the most important components of building energy use is space cooling. Again, vapor compression cycles are pretty much it for space cooling today, so there's been virtually no innovation in the cooling sector for about the past 70 years. And the BEETIT program seeks to look at novel cycles that might achieve building space cooling with much lower energy use, and also use refrigerants that don't have quite the greenhouse gas potential that the things that we use today do. And then finally, GRIDS is a program designed to develop novel, very large-scale energy storage devices that enable the deployment of renewables. So, of course, a huge barrier to the deployment of solar and wind is the variability that you see over various time scales. There's variabilities over seconds to minutes, over sort of minutes to hours, and over days to weeks. And we're really focused here on the minutes to hours variability. And so these kinds of energy storage solutions are really vital to the deployment of renewables. So that's what we've done. That's how we spent out our first $400 million. We have only ever been funded through Recovery Act funding, so continuing resolutions, I'm afraid, don't really help us very much. So we're sitting tight and waiting for our new Congress to do something about budget, and then we'll move forward from there, including, I think, quite likely in the information technology space. So in the last slide, I will make a shameless plug for our energy summit that will happen February 28, March 1st and 2nd down at National Harbor. This is a really outstanding event. We're expecting on the order of 2,000 participants from the science and business community. And for those of you who are around and looking for something to do, it'd be wonderful to have you join us.